Right, so what we're going to do is let's oops, that was the oldie new. Okay, so so I've done this enough, sort of the beginning, but one of my little soapboxes has to do with the fact that there are two things going on here: the declaration of the variable and the assignment of the variable. Those are two different things, even though we often do them on one line, usually just for these little test methods. When we're defining a class and we define these as instance variables, then it is better to define the instance variables separately and do the instantiation typically in the constructor. But okay, so now I've I've defined this as, again, I've defined it as the interface, and I generally prefer to do that in this case, even though we have nothing but tree sets. But just in general, declare your variable to be as abstract as possible. And let's just put a bunch of random stuff in there. Okay, so let's just generate, okay, just to illustrate, I'm gonna I'm gonna create 15 values that are gonna be between 0 and 9. Again, have this silly off by one thing. Okay, so I'm creating 15 numbers which are going to be uniformly distributed between 0 and 9. So there are only 10 of them, but I've made 15 of them. So what do you think is going to happen? Am I going to get 15 values in here? If this were a list, then I would. But because it's a set, even though I'm creating 15 of them, no matter how many I created, I'm only going to have at most 10 and possibly fewer. Let's see. Okay, I have fewer. Look, 1, 0, 1, 2. I didn't generate a 3 or a 5, 6, 7, 8, 9. So a 3 or 5 are missing. You know, they weren't generated, but they were, you know, I generated 15 of them, and I wound up with 2, 4, 6, 8. Okay, why? Because sets cannot contain duplicates. So whenever it generated a duplicate, it was rejected. Okay, so this. Okay, let's add our old you can tell I like old Marx Brothers movies, but that's just me. Your mileage may vary. If you've never seen Marx Brothers, then you're missing out. Okay, so I'm adding these in just some order. and they will appear not in the order I've added them, not in some random order like in a hash set or a seemingly random order, but in this case in, well, it looks like alphabetical order. All right, now, here, remember I said that the default compared to comparable is lexicographic. So let's add another one and see what happens with that. So where would you expect that to show up? It starts with an A, so you'd want it to be, you'd expect it to show up here, right? Let's see if that's what happens. That's not what happens. All right, why?
ASCII, because it's the capital. ASCII 2, right? Because it's the ASCII 2, the A letter is bigger than the...
Yeah. In other words, the part of the lexicographic ordering is that capital letters always come before lowercase letters. Right? That's the way it behaves. So if you expect it to be alphabetical, it's not. So what if you want it to be alphabetical? Well, then we'd have to write a comparator interface. Now, the other okay, let's let's add 15 of these. Remember, this local date time is something that that we can that kind of represent well, times. And what's valuable about that is we can use this is useful for timing certain operations. Like if you're writing a larger program and there are certain parts where it may take a while, and you want to know, okay, how long does this section of the code take? What you can do is you can, by repeated calls to now, if you call now before you do it and you call now after you do it, and then basically subtract the two, then you can find out how long it took. But what we can also do is let's add some seconds, and let's just add a random number of maybe you don't want to add that many seconds. Let's add up to 1,000 seconds. Oops. Okay, that's kind of running off the screen. Let's kind of look at them kind of stacked up. All right, so we can see here that what's happened, okay, so everything is today, but if we look at the times now, we see that the seconds kind of start clicking up. See the way this is today, this is the time, and this is all, I think, down to nanoseconds or whatever. So 8:38, 33 seconds, 8:38, 39 seconds, etc. And they were added in random order. They weren't added, but this kept them sorted. So that's kind of the key there. Okay, so now supposing, let's take, this is just, supposing we wanted this to be in reverse order for whatever reason. In other words, the order that it gave it was kind of alphabetical going up. What if we wanted alphabetical going down? And in many applications where you see things in a table, you can kind of click on the heading and it'll either sort of going up or going down. You've kind of seen that, right? So it's something that sometimes you want to do. All right, so supposing we wanted to do that. Now we can't do that out of the box here, but what we can do is we can write a comparator. So let's call it reverse lex for the strings. And so what we do is we say we implement the comparator, not comparable, okay? NetBeans has just been a godsend when it comes to this. So comparator was in this other package. It couldn't find it, so we did fix imports, and it found it. And now it's complaining. It says, okay, we have an interface, and it hasn't been implemented, so we just sort of click on it, and we say implement all abstract methods. We see that now a bunch of these things come up, and that's because of something that Java did that I personally find a little questionable, which is to put stuff in that I wish they hadn't. But anyway, but compare is really the only interface, the only method that you need to do. And again, this unsupported operation exception is something that happens. Okay, so now what we want to do is, this is kind of a trick for reversing the natural comparison. We know that because string implements the comparable interface, we know that it has compared to like that. So this would actually do the same thing as what the string does. But if we minus that, now it's going to do the opposite. And I can see that in my slides, I think I inadvertently said compare to in my slides. I will fix that and upload a correction. Okay, so what can we do about that? Well, I'm going to what we do is we pass an instance of the comparator to the constructor of our tree set. If we kind of look at this, we see there are various, the constructor is heavily overloaded. We can either create an empty one as we did before. We can actually give it just any collection, or we can give it a comparator. And don't worry about the strange syntax they have here. It's a little bit beyond what we... Okay, so what this says is now this tree set is going to use the compare method of this comparator to do its comparisons instead of the default. And now, in this particular case, actually, let me, that's going to kind of screw things up, isn't it? Tell you what, let's, let me create my copy first, and then now. Unfortunately, it would have been nice if they'd given a constructor where you could give it a comparator and a collection as well, but they didn't. So first I'm going to create a copy, and actually I tell you what, just to kind of put a little bit of a point on it. Okay, I'm going to create, and this is absolutely one of the nice things is that I can take contents of one collection and put them into another, and then they'll obey the rules of that particular collection. So if I create a copy and I put it into a hash set, now they're not being kept in order anymore. But then if I take those same ones and I put them into a tree set, now they're going to be kept in order. And I have to kind of do this little dance simply because they did not give me a constructor that would give me both a comparator and and another set. Okay, so what I'm expecting, and unless I screwed it up, I'm expecting to see these names starting with Zeppo. You see? And in this case, this was pretty easy. And in many cases, there's not a lot of code you need to write for this. Tomorrow, what I'm going to do is I'll then just kind of work on some other comparators. Specifically, we could write one for our cards, because cards don't implement the comparable interface, and we don't have an ordering that's specified from that. But there is a conceptual ordering that we can have, namely. Clubs, diamonds, hearts, spades is the ordering that, the arbitrary ordering that people have come up with, and then the value of the cards would be the secondary one. So, and we can actually have comparators that sort them first by suit and then by value, or first by value and then by suit, and we can actually have one of each and then decide on the fly which one we want. But that's for tomorrow.